Welcome back to the channel. So today in this video we are going to attempt question number 5 and onwards of miscellaneous exercise of sets class 11th CBSE mathematics. So question number 5 is show that if A is a subset of B, then C minus B is a subset of C minus A. So question number 5. Let us suppose we have an element X which belongs to C minus B. This means that X belongs to C and X does not belong to B. This will imply that X belongs to C and X does not belong to A, as A is a subset of B. So this implies that X belongs to C minus A. Therefore, C minus B is a subset of C minus A. Question number 6. Show that for any sets A and B, A is equal to A intersection B union A minus B, and A union B minus C is equal to A union B. So to solve question number 6, let us take right hand side of the first very part. So right hand side is A intersection B union A minus B. So this will be equal to A intersection B union A intersection B complement, as these two are equal. They are one the same thing. This will be equal to A intersection B union B dash. This is because A intersection B union A intersection B complement will be equal to A intersection B union B complement. These two are one and the same, meaning that this very part is equal to this very part. So this will be equal to obviously A intersection a universal set, and this will be equal to set A, as is clear from the laws, and this is our left hand side. Now let us take the left hand side of the second very part, which is A union B minus A. Now this will be equal to A union B intersection A complement, because these two are one the same thing. Now this will be equal to A union B intersection A union A complement. As we know that A union B intersection A complement is equal to A union B intersection A union A complement. Now this very set is again equal to universal set. Then this will be equal to A union B intersection universal set, and this again will be equal to A union B, which is our right hand side. Moving towards next question. Using properties of sets, show that A union A intersection B is equal to A and A intersection A union B is equal to A. Now let us take the first part of question number 7. Here we are having A union A intersection B is equal to A. Taking left hand side, A union A intersection B. This will be equal to A union A intersection A union B. This is the distributive law, as we know. And this will be equal to A intersection A union B. And this whole set will be equal to set A, which is equal to right hand side. Now let us take part number 2. We'll have to prove A intersection A union B is equal to A. Now let us take left hand side of this very part. It is A intersection A union B. This will be equal to, again from distributive law, we'll be having A intersection A union A intersection B. So this is again the distributive law. So A intersection A will be obviously set A, because the intersection of set with itself is the set itself. So we'll be having A union A intersection B. This again will be equal to set A, which is our right hand side. Towards the next question. Question number 8 is show that A intersection B is equal to A intersection C need not imply that B is equal to C. So this is question number 8. Let us prove this very question with the help of an example. Let us suppose we are given with a set A having elements as 1, 2, 3 and 4. We are given with set B with elements as 3, 4, 5 and 6. And another set C with elements as 3, 4, 7 and 8. Then what is A intersection B? So here the common elements of A and B will be taken. So the common elements are 3 and 4. So this set will be having elements as 3 and 4. And what is A intersection C? So here again we'll be taking the common elements of A and C. So the common elements of A and C are 3 and 4. So this set will also be containing elements 3 and 4. So thus here one can see that these two sets are equal, which means that A intersection B is equal to A intersection C. But one can observe that set B is not equal to set C. So this is what we needed to prove. Now let's move to question number 9. Question number 9 is, let A and B be sets if A intersection X is equal to B intersection X is equal to an empty set, that is phi, and A union X is equal to B union X for some set X, show that A is equal to B. So this is question number 9. So here we have A union X is equal to B union X for some set X. Now let us use A intersection on both sides. That is A intersection A union X is equal to A intersection B union X. Now this set will be equal to set A. On right side we'll be applying distributive law, which is A intersection B union A intersection X. So this is the distributive law. Which implies A is equal to A intersection B union phi, as it is given that A intersection X is equal to phi. This implies A is equal to A intersection B. That implies A is a subset of set B. Now let us suppose this first. Now again, A union X is equal to B union X, or B union X is equal to A union X. It's one the same thing. Taking B intersection on both sides, we'll be having B intersection B union X is equal to B intersection A union X. So this very part, this will be equal to set B. And on right hand side, we'll be again applying distributive law, where we'll be having B intersection A union B intersection X. So this will imply that B is equal to B intersection A union phi, as again it is given that B intersection X is equal to phi. That implies B is equal to B intersection A. This implies that B is a subset of set A. So this is second. So from first and second, we are having that A is a subset of B and B is a subset of A. This is only possible if set A is equal to set. So this is what we needed to prove. Question number 10. Find sets A, B and C such that A intersection B, B intersection C and A intersection C are non-empty sets and A intersection B intersection C is equal to phi. So this is question number 10. Now here we have to find three sets A, B and C which satisfy the given condition. Now let us suppose we are given with set A having elements as 3 and 4. We are given with set B having elements as 4, 5 and we are having set C with elements as 3, 5 and 6. Then what is A intersection B? One can observe that we have only one common element, that is 4. So this intersection will be containing only 4 as an element. So this is not equal to 5. Now what will be B intersection C? So here again we have only one common element, that is 5. So this intersection will be containing only one element, that is 5, which is again not equal to an empty set. And similarly, what will be A intersection C? Here again we are having only one common element, that is 3. So this intersection is having element 3. So this is again not equal to 5. So this satisfies the given condition as per the question, that is these three sets are non-empty sets. Now what is A intersection B intersection C? So here this will be equal to A intersection B intersection C, and that will be the common elements in set A intersection B and set C, and we can find that there is no common element, so this will be equal to an empty set. So here the given condition is satisfied. Note that in this question we can choose some other such types of sets as well. Hope this makes sense. Do subscribe the channel for more such content, and thanks for watching.